Did you know that thousands of students literally drop an entire grade boundary right here? We're talking about Cambridge Biology 9700, Section 6.2 on post-transcriptional modification. Most candidates are losing incredibly easy marks when dealing with introns and exons. And it's not because they aren't studying, it's because of a single, tiny theoretical mistake they make under pressure. Well, by the end of this explainer, you absolutely won't be one of them. We're going to dive into exactly what the examiners are actually looking for. So, why do ordinary revision methods completely fail when it comes to post-transcriptional modification? It's simple, really. Students are relying way too heavily on brute force memorization. But here's the thing. The Cambridge Assessment Framework doesn't just test your memory. It tests distinct cognitive domains, like how you handle and evaluate information. Memorizing the textbook just isn't going to save you if you don't use the specific mark scheme thinking that examiners demand. All right, let's get into Section 1, the costly exam mistake. The number one error, confusing key terminology under pressure. We dug through the Cambridge Principal Examiner reports, and, the data is glaringly obvious. When ordinary answers score poorly in this section, it is explicitly because candidates mix up their terms. When the clock is ticking, the brain panics, right? And suddenly words that look kind of similar completely swap definitions in your head. It happens all the time. Moving on to Section 2, Mastering Core Principles. Okay, let's clearly separate these core concepts once and for all. Introns are the non-coding sequences that get removed. Exons are the coding sequences that are actually expressed. Examiners demand this precise definition from you before you even attempt an extended response. If you blur these two up, your entire downstream analysis just falls apart completely. Think of introns as the interruptions that need to be cut out, and exons as the essential expressions. To lock this in, here's a high-retention memory hack straight from the source material. Create a custom mnemonic using the very first letters of introns, exons, and the modification stages. Seriously, I highly recommend taking 5 seconds right now to write down a memorable phrase that links I for introns to removed and E for exons to expressed. Building this personalized mental trigger is exactly what separates average candidates from those top-tier scorers. Now, in just a moment, I'm going to show you a hidden examiner clue that changes your answer completely. But listen, you cannot afford to miss the framework we're about to cover next, because without it, that hidden clue is completely invisible. You literally have to have the right lens to spot what the examiner is secretly asking you to do. Let's dive into Section 3, the method mark strategy. Here's the secret. Marks in Cambridge Biology are awarded for the process, not just your final conclusion. This is the 4-step framework you absolutely must use. Step 1, state the concept, like defining an intron or exon. Step 2, pull evidence or data directly from the stimulus materials provided in the question. Step 3, apply scientific reasoning to connect that data to your concept. And Step 4, lock it all in using precise examiner wording. If you connect post-transcriptional modification to the provided graphs or tables using these 4 steps, you are actively checking boxes right on the mark scheme. Just notice the difference between a superficial answer and a top-band answer. A flawed response might mention an exon, sure, but it completely lacks the context of the data provided. It just skips straight to a memorized conclusion. On the flip side, a top-band answer systematically walks through our 4-step framework. It identifies the given info, extracts the relevant data from the stimulus, applies the correct analytical framework, and then presents the final thought using precise terminology. Guys, this is exactly what analytical depth looks like. Next up, Section 4, Top Examiner Warnings. These 3 bullet points are massive pitfalls that rob candidates of easy marks every single year. First, forgetting units in your calculations. If you're analyzing data related to gene expression or modification rates, a number without a unit is just considered incorrect, full stop. Second, forgetting to double-check terminology. And third, providing answers that lack specific context. You simply can't just give a generic textbook definition of an exon if the question is asking you about a specific mutated sequence provided in a case study. Context is everything. Listen to this exact quote directly from the Principal Examiner report. Candidates consistently confuse key terminology. Always define terms before using them in extended responses. This is incredibly authoritative. The examiners are practically begging you to take a brief moment at the start of your paragraph to explicitly state what an intron or exon is before you launch into your complex analysis. Doing this establishes your baseline knowledge and secures those fundamental marks immediately. All right, on to Section 5, the Deconstruct Solve framework. When you hit a wall in the exam, just follow these 5 steps. First, identify the given information. Extract it directly from the tables or graphs. Second, break the problem into logical steps. Seriously, don't try to solve a complex modification question in one giant leap. Third, solve it systematically. Fourth, evaluate your evidence. Check for reasonableness, identify limitations or any assumptions made. And finally, step 5, make justified recommendations based on your findings. This deconstruct, solve, and evaluate methodology ensures complete analytical depth. When you're handling experimental skills in 6.2, you've got to select the appropriate test. You use a t-test for comparing means. You use a chi-squared test for categorical data. And you use correlation tests for relationships between variables. You absolutely must systematically plug your practical work data into this framework, making accurate observations and identifying anomalies to draw real evidence-based conclusions. Here is a major takeaway for you. Cross-topic connections equal higher marks. The principal examiner reports specifically highlight that candidates who reference integrations with other syllabus areas achieve significantly higher scores. So when you're talking about post-transcriptional modification, don't just put it in a box. Connect it to mutation impacts or protein structure or evolutionary advantages. Show the examiner you understand the entire biological architecture. That's a real game changer. So we've built an incredible theoretical foundation today, right? We have the definitions, the 4-step framework, and the deconstruct, solve, evaluate method. But what happens when you have the perfect biological understanding, but you misread the examiner's command word? What if they ask you to evaluate, but you only describe? Well, that is the hidden diagnostic cliffhanger that will completely cap your final grade, even if your biology is totally flawless. Before we solve that mystery, let's quickly cement what we've learned today. 1. Master your terminology. Introns are removed, exons are expressed, and you must define them first. 2. Apply the method mark strategy to ensure your reasoning aligns directly with the stimulus data. And 3. Use the deconstruct, solve, evaluate framework to logically tackle complex data analysis. You are now fully primed to secure those high marks in post-transcriptional modification. But to solve the mystery of how command words dictate your mark band, you need to watch our next explainer immediately. Make sure you subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations, and click the explainer right now to master those command words. After all, what good is knowing the right answer if you're answering the wrong question?